Let's see which one looked hard. I heard this one was hard. I'm not sure how hard it really is, but that's what it said on the site. Okay, so we have Robbie joining us. So it doesn't look super hard, does it? But let's see. Okay. Hey, Robbie. All right, so we draw the AX center. Let me do it like this. Should I use the in-center X-center lemma to draw it, or just draw the X-center? I'm going to just draw the X-center.
Don't draw it like that. I think I said one time how to draw it better.
Oh, yeah?
So you take the angle bisector tool and click on segments BC and BA.
Like this, or BC and BA?
Segments.
Segments.
Like the segment.
Oh, okay. So let me delete the arrays. So this is the AX center, but I still do BC and BA, or?
Yeah.
Okay. Oh, it does both of them. So that way you get it really easy. Nice. You get the in-center and the X-center. I like it. That's cool. Let me
I actually did this problem before. It isn't really hard.
Really?
Yeah.
All right. You guys want to try another one? So I think, let's see if we can find, I think this one might be harder. Let's see. So we have a triangle ABC, and because this has both the in circle and the orthocenter. Let's see. So whenever you have the orthocenter of the contact triangle, I feel like it's a hard problem. But we'll see. So we want D, E, F. And H star is the orthocenter of that. I don't like, why don't I just call it H prime instead of H star? That would make things easier. Equals. And then, so really, I mean, we only need to show it. So like by symmetry, we only need to show, because we just need to show H is on PX. So X is AI intersect QR. Okay, so we need to draw the three altitudes. Okay, yeah, let's draw the actual orthocenter. So that's the actual orthocenter. So let P, okay, so this is P. And X is the intersection of, oh, we need to draw all three. Okay. So P, Q, and R. And then we draw AI intersect QR. and we want to show that H lies on PX. So I'm going to make it nicer in just a second. But if this is X, we want to show that H lies on PX. H prime lies on PX. Maybe we could use some other problem about, because there's a couple of problems using point H prime, right? Like I think, is IH prime parallel to OH, where O is the circumcenter of ABC?
No, O lies on IH prime.
Oh. All right. I don't know how hopeful that will be, but who knows?
This is true when H prime is the orthocenter of incentral triangle.
Yeah,
H prime is parallel to OH. When H prime is the orthocenter of incentral triangle, not context triangle.
not the what?
Now DEF is the context triangle, but if DF were incentral triangle, intersection of angle bisectors and the sides, then IH prime is parallel to OH.
Oh, yeah, you're right. Yeah. You need to draw the intersection of the angle bisectors with the sides, not the incentral. Yeah, I see what you mean. So is this a little bit easier to prove that H prime I and O are collinear than that other fact that I mentioned?
Yeah.
Okay.
This
Much
is just an inversion.
Okay. Sorry. Oh, Robbie just wrote it. Yeah, they're collinear.
You intersect AP and AI with the circumcircle of ABC.
Yeah. There we go. All right. This problem is hard for me, but yeah, maybe you guys will have some ideas. Let's see. X P H prime and X. So yeah, the problems are, the points aren't defined in that complicated of a way. So yeah, how do we want to use that H is the orthocenter? I guess that's the question. So we could use that the reflection of H over EF lies on the circle. But yeah, so showing these are collinear, that's is that like a homophogy about I or something?
Inversion. I know
Inversion.
what to inversion.
Inversion. Okay.
You invert about the in circle, and then the circumcircle goes to the 9-point circle of DEF.
Okay.
And then the centers of those circles don't map to each other, but they still lie on a line.
Okay.
And so IO and 9-point center of DEF are collinear. And since I is the circumcircle of DEF, then all sorts centralize on it.
Okay, that makes sense. And Ravi says the X or inversion about, so it could also be inversion about the X central triangle. That's interesting. But yeah, because I in this point times IB is IB squared. I think I've seen that idea before. I just forgot it until now. Interesting. Yeah, so how do we use that H prime as the orthocenter of DEF? Let's try, you know, this looks a little bit like the Sharky Devil, right? If T is the mixed linear touch point, then TI, BC, and AH prime concur. That's interesting. I did not know that. Okay, so basically, let's draw the mixed linear touch points. So that's the mixed linear touch point. And you're saying AH prime passes. Are you sure about that? So,
well, if you intersect DH prime with in circle and name it, for example, Q, then AQ passes through that point, not AH prime.
oh, if you intersect what with the circle?
Actually, no, it's not, I guess.
Oh.
I only know that IK passes through midpoint of DH prime.
IK the midpoint of DH prime?
Yeah.
That's interesting.
And that is the point of inversion of the mixed linear in touch point about the in circle.
Okay.
But it up, that is useful.
Yeah. Yeah, I'm gonna hide it for now.
I think it may be useful.
Okay.
You can write ratios. You don't need to write ratios. We just need to prove that I is a midpoint. Can you name the intersection of AJ with BC?
Yes.
Sorry. I thought KL and P are collinear. Okay. It's probably not useful.
So yeah, we could draw the midpoint of EF too. So yeah, LDL is equal to IS is equal to H prime L.
Can you delete point L for now? Actually,
Yeah.
can you check that if AM DH prime intersect on in circle?
Yeah. Did you say
DH prime AM.
AM and
It's probably not useful. I was just curious. You can
on the in circle. I don't know. I was thinking. Yeah, it looks true. Yeah. Yeah, I think I've seen that fact before in like the Sharky Devil stuff. I don't remember the proof, but it looks familiar that they intersect on the in circle. It is because the Nagel Chevian and the mixed linear Chevian are orthogonal. Oh yeah. So then from that, it's just an angle chase once you use that fact. Yeah, so you're saying if we reflect D over L, oops. Basically, we have this, and they're orthogonal because AD prime C is similar to ABM. And so from there, it would follow, I think you're saying that this would pass through that point. I don't, because this passes through the topmost point. Yeah, because these are isogonal. Yeah. I see what you're saying. Yeah, because basically if these are isogonal, then the intersection of those points with the end circle will be basically like parallel to EF. And also since DH prime and DI are isogonal, their intersection points will also be parallel to EF. But we know DI passes through that point. I like that. It's nice. Okay. So we know that they concur. I like it. No projective geometry needed there. You just use that fact and that proves it. All right. Let's see, is there a way we can use projective geometry? Yeah, that point X, it's defined in a really weird way where AI intersects QR. That's kind of hard for me to think about how to use that. I feel like there's so many of these theorems where you want to show like a line passes through the orthocenter of a triangle. Like there's all this stuff with like anti-Steiner points and like, I don't know. There's a lot of theorems with lines going through orthocenters of a triangle. I think Jean-Louis Aimé had some kind of theorem, might have been related to this on his webpage.
Can you delete the stuff about mixed linear point?
Okay. So just delete point M.
M and K.
M and K. I wonder, what if we let AH prime Like, I wonder if we could try to project those 3 points through A onto the circle or something. Is there some other special point that lies on this? Well, that would be interesting if these are concurrent right here. Yeah, they're not. Does this line pass through? I feel like we would have already seen this. Yeah, it doesn't. Maybe we could let QR intersect BC, and then we could like try to project through that point. So let's see. So we have P H prime X. We get Q, C, and I don't know if there's something special about that point. Yeah, not that I know of. Maybe it's better to project onto the circle itself, because that would be like more symmetric. Then we want to project from a point on the circle. You know what? Maybe. Like, what if we projected through point D onto the circle? So P, H prime, and X, I don't know where X would go, but we know where P and H prime go. Let's check out DX. Yeah, like, I don't know if we could say anything about that point. Or maybe we try inversion somehow. Although, yeah, I don't think that's that easy. So angle BA. I don't think. So yeah, CAX bisects angle BAC. Like I wonder if we could find something like isogonal to AH prime. X H prime. Hello, you're using a property from the geometry marathon. Do you know what X56 is and X571 are? I haven't looked at the geometry marathon. X56 is the homothetic of the incircle and the circumcircle. Oh, X57I. Wow, that's an interesting fact. So to find the homothetic center, I'm not even sure if I remember, like if you have one circle inside another, you can't draw the tangents. So how do you find the center of homosity? I don't even remember how to do that. Well, okay, so it has to lie on the line IO, and it has to take one circle to the other. So yeah, it's like a point on IO, and then you calculate the ratio of the radii, and that's how you figure out where it is. Parallel diameters. That's right. That's pretty fascinating. I don't think it's going to help for this problem, but I guess you never know, it could. But it's really interesting. Okay. Maybe we could even project those 3 points through H. Because H, it seems related to point X, right? At least a little bit, because this is cyclic and, well, actually, I'm not sure about that. Yeah, I think we kind of just have to figure out the right thing to project through, which is not an easy problem, but what'd you eat? What'd you eat for dinner? Yeah, food has gotten so expensive lately. Like I've started eating out less and shopping more. Do you guys have Aldi in your country? They have the food there is much cheaper. The food here is cheap. Yeah. Yeah, food prices have gone up like 40%. It's like crazy. Is inflation or yeah, I don't understand all the supply chain stuff, but yeah, they've gone way up. All right. So we could try projecting through D. I wonder if there's some point like in harmonic conjugation with these three.
Can you name the intersection of AI with BC?
Yeah. Oops. I might have to zoom in a little bit. There we go. Let's see. ATXK is harmonic. And then what would you do once you have that point? Would you project TXK? You could project through D maybe? Okay, yeah. So how would we, let me think about that. So we want A, T, X, and K to be harmonic. So basically we want to draw BX and CX and see where they meet. So like, would this be point T? And then once we do that, we could like project through yeah, I don't what were you thinking we would do from there? Be right back. All right. All right, let's see what time it is. It's 11:03. I guess we can work on this for like another 15 minutes. And then if we don't solve it, we can try something else. Unless we make a lot of progress on it. I wonder if AX is like isogonal to something. Like, well, we know we know AX bisects BAC, but maybe AH prime is isogonal to something. Let's see. Is there anything special about DX, that line? We take this point. No. Just trying to find anything special about that line. Like if we let it intersect the circle at a point. Is there anything special about that? Oh, I wonder if L, H prime, and G are collinear. No. Yeah, I don't know. Yeah, I don't see anything too special about that line. So we could try to show H prime B over PD is XK over KP. Actually, that might not be so bad. That almost seems like bashable. Like we want to show H prime B over DP is equal to XK over KP. And K is the foot of the angle bisector, so we can calculate KP. That might come down to like a calculation, right? Because we know DH prime is twice IS. Yeah, maybe that's not so bad. I mean, it might be a little ugly, but I don't know. Maybe that could work. Right? It seems like in theory that could be bashed, right? BH prime over
think, yeah.
everything is
Since
able
we
to be
can practically calculate everything in terms like of sides of ABC, and it would be really, really ugly, but it should work.
Oh, but KX is a little bit harder. So
If we I think that we can actually calculate that also, since we would need to like make a difference between angle bisector chavins, and those are in theory like calculatable.
so like KX, how would we calculate that? I think that might be a little harder, right?
It is the hardest part, probably.
Yeah. Yeah, because then you need like the length of an angle bisector, and that's just like really messy. But maybe there's some kind of similar triangle. So DH prime is twice IS. So it's kind of like we want the ratio IS over KX. If T is the X circle touch point, then PDKT is harmonic. I think I've seen that fact in the so basically you're saying or something like that. So are you saying that's point T? Oh no, we got to reflect about the midpoint. Sorry. I think I've seen that before because you could project, because if you project them perpendicularly, P goes to A, B goes to I, K stays here, and T would go to the X center. And it's well known that A, I, K, and the X center are harmonic. So I've seen that before. Can we take those and project it? I mean, maybe that could be useful. I don't know. So can we somehow project these 4 points into P, H, X, and another point? Maybe
best solution by massive calculations by proving PD over PK equals to H prime D over XK.
Okay. You want to type it up in the
I
chat?
calculated them all. I can write them in the Discord chat because it's a little messy.
It's very long. Yeah, write it in
Not
the.
that long, but messy.
Okay. Yeah, write it, type it up for now, and maybe while you're typing it up, I can see if Ravi's idea might work. Because basically, if we draw the parallel through D prime to these others, does that pass through? That looks like it passes. I can't tell if it passed through the midpoint of arc BAC. I think it might. No, it doesn't. But maybe. Let's see. Okay, so yeah, like maybe we would have that point, for example. Yeah, let me shrink. Okay. So we have PDK, D prime is harmonic. And then if we projected those, we'd get P, we want to show PH prime X that. Is there anything special about point T? Yeah, I'm not sure. It looks interesting. But I'm not sure. What if instead of this line, we like, yeah, we need to find something special about point T. And I'm not sure if I see it right now. Yeah. Let's see. So Serdar, you're writing it up in the Discord.
I'm writing it in paper, and I will put the photo of it.
Okay. That's fine. Oh, sorry. All right. So in the meantime, let's try another problem. Okay, so you said you did this one before. We could try this one. Okay, so this one has an X circle and an orthocenter. So this way we get, okay, but really we're gonna wanna do, yeah, the BX circle. So I'm gonna rotate the triangle. This way we get both the in-center and the center. So let this be I. And this is J. Those are collinear. Let me drop a perpendicular. I could draw both. Oh, yeah, I want to draw both circles. So through that point, and AI and J are collinear. And it touches BC and CA. Okay, so we want this to be L. And this should be K. And then H is the orthocenter of ABC. Oh, so BH is just the altitude, so that's kind of silly. We just want to show that the altitude from B and EF and KL are concurrent. Is this well known? It might be. Oh, are you talking to me or did Serdar put the chat on Discord? Oh, bashing? No, I don't. I don't usually like bashing, but if it's the only way, sometimes I'll post a solution like that. So BHEF and KL. What did I do wrong here? So DEF. So it's tangent to BC and CA at K and L. Did I do everything in this problem right? H, we have the in circle. We have the BX circle. Touches BC. Oh, I did these points wrong. B, so this is D. Okay, this should be E. And then I think it works. There we go. So basically we're saying KL and EF meet on the B altitude. Okay, let me make this look better because obviously it looks quite horrible right now. There we go. That's better. And I don't even really need to draw this. I could for this. I'm just going to draw this point. Basically, we want to show that BG is perpendicular to AC. It feels like the Iran lemma or something. I don't know. It feels kind of like the last problem we did too, right? Something like that. It's a well-known fact. Okay. Is this like the Iran lemma, but for the X center instead of the in center, or? Well, because we know. Do you know the proof of it? I could just type it up really quickly. And then I could try the last problem. So I know, Stefan, you said you did it before, but we could try it and see if we can find the same solution. Ah, you forgot the proof. So KL is parallel to CI, right? you know, IE is perpendicular. We want to show BG is parallel to IE, but we know that CI is parallel to LG. So I don't know if that might help because I wonder if CI passes through this point. Is that the Iran Lemma or something? No, it doesn't look like it necessarily. So but what we could do, so we know that B, E prime, and L are collinear. And we know we want to prove these are parallel, which I don't know if EF and BL yeah, that doesn't look like.
By the way, I have sent proof.
Okay. Let's see. Oh, wow. So it's a trig calculus. Use the half angle formula or.
Yeah, I used it a bunch of times.
And a lot of cosines. Yeah.
Yeah.
Wow. That's pretty interesting. I'll have to look at it more after the session. Actually, let me see if I can copy this image into GeoGebra. I think it should be doable. Let's try it. Algebra. Paste image. Don't use my camera. I'll do it later, but I think there's a way to do it. Okay, so I'll go back to, let's try this one. So Stefan, you said you solved it earlier. Let's see if we can do this. So IA is this point. M is the reflection of IA over BC. So that's M. And we want to show that AM is parallel to the line. Okay, the orthocenter of IACB. So let's call that H. Is it not like that it's IA or something? Oh, because I need to put 4. I forgot to do that. There we go. So I mean, basically the Euler line. We want to show that AM is parallel to the Euler line of this triangle. Call it O. We want to show that AM is parallel to OH. And we could draw the incenter here. Call it I. It's kind of an interesting problem. Yeah, why don't I draw the circles? Draw the end circle. Oops. Then I will draw this one. Oops. And this is like symmetric. So those 4 points are all collinear. We want to show AM is parallel to OH. Let's see, where would A? So those are like collinear. I'm guessing that's obvious because these are isogonal. O is the midpoint of arc ABC. Yeah, okay. So yeah, that is obvious. So we can draw that segment.
It is just proving IH is parallel to AE, and that's obvious.
IH is parallel to AE.
Yeah, if we prove it by ratios, we can prove that IAO over IAA equals to IAH over IAM. If you prove that parallelity.
IAH over IAM. Because IAH is twice the distance from this to BC, O to BC.
No, we write that IAM equals to twice as IAE. And also we know that O is the midpoint of IAE, IAI.
Mm-hmm.
So we got that we have to prove that IH is parallel to AE. And this is obvious because H is the reflection of I with respect to midpoint of BC.
Okay, it's the reflection of H with respect to the midpoint of BC. Okay.
Yeah, and it's well known that these two lines are parallel.
Okay. So let me see. I could write. I'll just write that up really quickly for the viewers on my channel. Shouldn't take more than like 5 minutes. So we want to show IH. IH over IAM equals IAO over IAA. But so so we calculate IH over IAE, right?
We write E is the midpoint of IAM and O is the midpoint of IAI. So we want to show that IAI over IAA equals to IAH over IAE.
Okay, so O is the midpoint of IAI and E is the midpoint of IAM. So basically this is equivalent to II. So yeah, we can rewrite this as we want to show IAH over IAE. Okay, because IAO is half of that, and IAH. Okay, yeah. So this is half of something. I know I'm confused. IAM is double something, and IAO is half of something, right? So yeah, so that means we want to show IAH over IAE is equal to IAI over IAA. That's what you're saying, right? But HI is parallel to AE because so AE is a Nagel-Chebian because IH passes through IF and by the Iran Lemma. So this is true since IH is parallel to AE. And that's true because IH passes through the midpoint F of BC. And IF is parallel to AE from the Iran Lemma. That makes sense. All right. So have we covered everything? Just this one, I guess, is so we could try to find another problem. I might, because let's see, I have 7.
If no one knows the solution of that, we can solve it.
The solution to this one?
Yeah.
Okay.
No one knows the solution.
All right. Oops. These were a little bit easier than I thought, except for the one problem that Serdar put on Discord.
Intersect CI with DF.
Okay.
we want to show that HG or HE is CL over CE.
HG over GE?
HE.
HG over HE is CL over CE, because that would show that these are parallel.
Yeah.
Okay, so you're defining G as the intersection of the perpendicular from B to EF. Okay, and then you want to show those are parallel.
Can you intersect AG with ED?
AG with ED?
Sorry, BG. I thought A was the top one.
Oh, it's all right.
Now we want to prove that E is the orthocenter of LGM.
E is the orthocenter of LGM. So we know this perpendicular. Well, it depends how we define things. Yeah. How do you define G?
I define G as BL2 that intersect EF and ED.
Okay.
So you can delete the segment GK.
I can delete GJ. Did you say?
No, GK.
GK.
Then LM, BI, and EF concur.
LM, BI, and EF. That's interesting. Should I delete point H for now? Oh. I should call it, well, I'll just leave it there for now. I'll be right back. All right, I am back. Let me make this look better. So I'm going to draw this point and then hide a bunch of stuff. What was N? it's like this. So yeah, it looks like these all concur at a point.
Oh, I think I have a solution.
Okay.
So label the midpoint of EL.
Okay. So that's the midpoint of AC, right?
Yeah.
Well, oh, I'm doing
Sure,
reflecting. I don't like O. I'm going to call it P. Okay.
One part of Iran Lemma is that PE is equal to PN.
PE equals PN.
Yes.
So first of all, do we know that, like, so the point N.
Let M be the intersection of BI and EF.
BI and EF, okay.
So PE is equal to PN. That is by Iran Lemma.
Okay.
And since PE is equal to PL, we have that ENL is 90 degrees.
Okay.
I may have used that MN and L are collinear.
Okay. Let's see if we can prove that. Oh. So we have EFDE.
Okay, so let M be the intersection of BG and LN.
BG.
BG.
BG
So
and LM. Okay.
just defining M in a different way.
Okay. So we define N. BG. So are you saying we define M like this?
Yeah.
Okay.
I already proved that ENL is 90 degrees.
Yes.
And we know that MG is perpendicular to LE.
Yes.
Then
so we have an orthocenter.
Yeah. And ME then is perpendicular to GL.
Yes.
And this should prove that ME and D are collinear.
Okay.
Oh, actually, well, we know that DE is perpendicular to HC, but we don't know it is perpendicular to GL.
Yeah.
So we need to prove that ME and the D are collinear.
Okay. I'm gonna hide point H for now. Yeah, I like that idea because yeah, we know DE is yeah. Yeah, maybe we can, yeah, I'm trying to see if we can use the radical axis theorem somehow. I wonder if E, B, and this point are collinear. Yeah. If that were true, yeah, that might be equivalent to the problem if we can show that ED and that intersection point are collinear. Okay, let's see. Does KL bisect IE? No. All right, looks like Robbie is back. What if we drew that circle? Hey, Robbie. Yeah, it's like it passes through that point. Oh, so it's going to pass through this point. But we don't know that this. So yeah, we can actually calculate, I think, yeah, by an angle chase, I think we can show all these points lie in a circle, right? Hello. Because yeah, we know that we can find the angle between CL and AJ. That's just, yeah, by an angle chase. So we know all those points are cyclic. And once we know that, then we wanted to show ME and D were collinear. So basically we could show ME and O are collinear and EO and D are collinear. Well, But to show EO and D are collinear, so maybe we could show MEO and then EO and D maybe. So ME and O we know are collinear, right? We need to show that EOD are collinear. So we want to show EO is perpendicular to CI. Yeah, I don't know if I'm just going in circles here or if this is helping. M is the intersection of the altitude from B to AC and LN. And N is the intersection of BI and EF. Yeah. Yeah, I feel like I know we've done this before on my channel, but it's a while back. So angle ENL, yeah, angle ENL is 90 degrees because by the Iran lemma. Because if N is the intersection, basically. Oh, sorry, that's not how the Iran lemma works. But if N is the intersection of EF and BI, then the Iran lemma basically says that angle ENL is 90. So that's true. You mean BNC is 90? Okay. Gives both. All right, you got a couple more minutes. So yeah, before I finish, do you guys have any sort of suggestions for the channel? Do you want the problems to be harder? Do you like the difficulty? Do you want me to pull them from a certain place? What do you guys think? Otherwise, I'll just keep continuing as I'm doing. I feel like today was a little bit easy.
In the Zoom, right? The Zoom problems, not the one you make videos on your own.
Did you say do the what problems?
You want problems for the Zoom, right? Not the one to do on your own.
Yeah, for the Zoom, yeah.
I think that problems are good.
Okay.
I think I can make suggestions in the future if I can find nice problems.
All right, thanks. All right, thanks. Yeah, and I wasn't even like wondering about like I appreciate if you guys can find problems, but I was just thinking about like, you know, how long it is, like how we do it. But yeah, I guess there's not really a huge amount that, yeah, we could change. Yeah. Yeah, Jean-Louis Saime, his website is like really interesting. He has like most of the stuff he has on his site are like general theorems, and some of them are like pretty like hard to prove. But most of them, like, they're not like Olympiad geometry problems, they're like theorems in general. But yeah, he has a couple with Olympiad. So yeah, I just continue to take from that, and I just go on Art Problem Solving Forum and look at his posts and, you know, other people's posts like Luis Gonzalez and all of them.
Also, actually, Telco's problems are nice.
Telv Cole, yeah. Yeah, he's really strong. So yeah, I'll look through his problems. All right, so I think I am gonna end it here since it's 12 o'clock, so, or 12 o'clock where I am. So yeah, thanks to everyone for sticking around, and so that we were able to do the session, so I appreciate it. And I'll see you next time. So for those of you, Telv Cole is, I'm not sure if he's a math professor, but for those of you watching on YouTube, if you want to join us in the future, feel free to email me at mgreenb801@gmail.com. The sessions are every Sunday at 8 a.m. US Central Time. So my email, mgreenb801@gmail.com. It's in the description of my video. So thanks for watching and have a good day.